Zuzana, and I'm responsible for external communication at Excalibur, and I will be the host for today's workshop. The topic for today is Introduction to Excalibur SAM as a cloud-native solution. Marek, our host, special architect, solution architect, and expert, will talk about today's agenda in more detail. But just for the purpose of the introduction, let me summarize today's content of this session. We will focus on the Streamed Access Management or SAM platform that we designed and developed. After that, Marek will show us cloud-native application architectural principles and how Excalibur SAM leverages them to deliver a scalable, resilient, and easy to deploy solution. You'll see the architecture behind the platform, experience detailed live technical demos to demonstrate its capabilities, and learn how Helm charts simplify deployment across Kubernetes, OpenShift, and Azure Kubernetes Service. We invite you to participate actively in the workshop by asking questions and contributing to the discussion at any time. But of course, there will be a dedicated Q&A session at the end. If you'd prefer to postpone your questions, please post them in the chat under Q&A and we will get back to them to those questions and we will answer them. But if you'd like to ask questions during the session, which we appreciate, simply raise your hand and we will give you an opportunity to ask or discuss directly. Marek, the floor is yours.
Thank you. So good afternoon again to everybody, and let's start with our today's session. Okay, a little bit about the Excalibur. I guess all the information is already well known, but I would like to repeat it again. Okay, so Excalibur is the Slovakia-based cyber security company which specializes in multi-factor authentication, privilege access management, and next-gen web authentication firewall solutions. So our mission is not only to help organizations to close their NIST gaps, but we like to help in the communities as well. So regarding communities, we are a member of the European Cyber Security Organization community, and our products or solutions are certified as cybersecurity made in Europe. We also gathered multiple ISO certifications as well, so you can trust our solutions that they meet the highest standards. Okay. There are many other details regarding the Excalibur as well, but I think I will continue with the presentation. So I would like to talk a little bit about the SAM as the Streamed Access Management. So legacy solutions like the privilege access management is just the legacy solution dedicated to a privileged group of a few users, typically system administrators. So they use these kind of solutions on daily operations, and basically that's it. But we would like to bring our solution for all users. So to be sure that access to the applications and platforms is secure. It is secured for the users themselves, and also we can look on this in the other way. So the applications are protected against the malicious activities performed by users as well. So this is our concept. This is our technology, which is called Stream Access Management. Typically, it consists of 4 layers. So basically, the first layer is already mentioned multi-factor authentication. So we developed and integrated MFA into our platform into our solution. And the multi-factor authentication represents strong authentication mechanism. We already had a workshop for these. I was presenting several details regarding that and some technology behind the scenes as well, with lots of details, lots of configurations, and so on. Second layer is the platform itself. We can speak about the user interface, which is called dashboard, and it is based as or it works as the web-based application. So the dashboard environment interface is accessible for all registered users, and the PAM functionality is available directly in this web-based dashboard. Regarding the third layer, we are speaking about the auditability and visibility. That means that everything, all activities, all configuration steps, all such um, details are visible and accessible directly in the dashboard. So uh, if needed, there is possibility to check not even the PAM session recording, but also all of these activity details, metadata, and also activity of the system administrator managing the Excalibur SAM itself. And let's talk a little bit about the fourth layer, and it is based on the AI large language models. So the AI engine is helping us in the our solution to recognize and detect many different aspects of user behavior, their activities, and so on. Okay, so let's move a little bit on, and I would like to talk today about the Excalibur SAM as the cloud native platform. So let's begin with the cloud native design principles. Okay, so the first major aspect of cloud native applications themselves is to utilize containerization. It's the technology very similar to virtualization, but in this case, we are talking about a very small and portable application images. And those containers typically contains all the necessary files, runtime libraries, other libraries, and binary files which the application needs. And basically, we can call that as the dream of every developer in the world. So if developer develops such application, he needs to somehow make the application portability and also full functionality in almost every environment of the users. So this is basically it. So we pack all necessary components and application itself into the container. Then we deliver the container into the destination environment. There we will run the container, and in such scenario, all the developers and also we as the vendor are 100% sure that it should run absolutely fine without any issues, without any lack of some binary files, some libraries, and so on. Um, Yeah, I was talking a little bit about the benefits as well. So another typical benefit is that the deployment is in this kind of applications very simple, and also it is quite lightweight on resources because we do not need to create dedicated virtual machine. We only need some existing environment, maybe existing server or virtual machine, where we can run the container itself. And typically, tools and utilities that we use are the Docker engine, the containerd as the runtime environment, which takes care about the running and managing the containers. And maybe there is some alternative made by uh, Red Hat, which is called the Podman. The other aspect of every cloud native application is to do not create monoliths, but to try to split the application into microservices. So each cloud native application consists of several microservices, and each microservice is developed, deployed, scaled, and running absolutely independently of each other. They can communicate with each other to keep overall application functionality, but almost every simple task can be run on dedicated microservice. So, for example, if you have some e-commerce application, so you can have separate services, for example, for user authentication. You can have a different microservice dedicated for product catalogs, maybe other microservices that will take care about the payment, about the order processing, and so on. And why it is important? Because microservices enable agility, they are fast, and also they enable a vendor to more quickly innovate and also to more quickly react if there are some bugs or some defects and so on. So in that case, the vendor does not need to take care about the bugs within the monolithic application. That will also need some reinstallation or upgrade in the customer's environment. We just need to upgrade and reload the proper microservice, and that's it. Other aspect of advantages of cloud native applications is dynamic orchestration. So I was talking a little bit about the deployment, but now imagine a situation where you need to manage hundreds or thousands of containers manually. So it's almost impossible job. Then we are talking about about the orchestration platforms, tools, utilities, and so on. Uh, Typically, platforms such or like the Kubernetes or OpenShift then come to place. So they enable administrators to automate the deployment of the applications, scaling, and overall management of all applications or containers themselves. It is very useful tool or tools or a set of tools to ensure that the applications can run smoothly, and also they can react flexible on actual demand or incoming load from the users. So these such tools or platforms then reduce manual work or of system administrators, They also optimize the resource usage because when there is a load, the orchestration platform takes care and will start another replicas of those microservices they are experiencing such load. If the load goes down, the orchestration platform will then terminate those replicas that are not needed anymore. So that's why we are talking about the optimization of resource usage. And also, we need to mention that this is the way how to keep all applications and their components highly available. So, for example, we have such a geocluster spread it across multiple data centers. And maybe one data center, there is the electricity outage, or there is the internet connectivity outage. So in that case, such geocluster will take care and will start missing processes of all needed microservices on different nodes of the cluster. So there is the scheduler engine, which is periodically checking if all is running as it was defined, as it was configured. So for example, as I mentioned, such e-commerce application, there are several microservices or microservice components. So for example, the login engine, and suddenly the node or the processes of Kubernetes on particular node goes down. So scheduler will take care. We'll get the information. Okay, the node is down. It is not responding anymore. There was running the login component or microservice of my application. So the definition is describing that I need exactly 2 or 3 replicas at least. So, okay, I will take care and I will run those microservices and replicas on different nodes. And that's it. Yeah. Resilience and fault tolerance. I was talking about this just a few seconds ago. And yeah, typically resilience is about the building applications that can recover very quickly and automatically. Yeah, so scheduler is periodically checking the cluster, the healthness of the cluster, and also there are so-called health check probes, for example, and those probes are, for example, checking each other, or the Kubernetes cluster is using those probes to check microservices and their appropriate containers for functionality. So we can define their cluster or scheduler. Please use this kind of probe and periodically check each microservice. And if there is proactively any problem detected, in that case, the microservice is considered as non-functional. So the scheduler will run another replica of the microservice, and the old replica is then killed down, stopped, maybe restarted. It depends on the exact use case. So this kind of mechanism then really minimizes the downtime and also keeps the users happy, and that's the goal. Okay, and scalability. Yeah, I was talking a little bit about it, about the, for example, higher load during the work hours in the day. During the night, there is no such demand for load. So cloud native applications are designed in such manner that they can grow scale up, and also scale down without any effort. And these can be done automatically by the, for example, Kubernetes or OpenShift clusters themselves. So in that case, I do not care if my environment is being visited by 10 users in the night or 10,000 users during the day. Because there is a built-in mechanism, which is, by the way, called the horizontal autoscaling. And that means if there's such demand on load, the horizontal autoscaler is defined based on several metrics. And if some of those metrics is over the threshold, so the horizontal autoscaler will take care and will spawn on run or start up new replica or replicas. And this can go as much as you have available system resources within your Kubernetes or OpenShift cluster. So yeah, you need to have enough CPU cores available, also enough amount of memory within your Kubernetes cluster. But if you have, the autoscaler can work automatically. If you don't, then you have, for example, two choices how to deal with such situation. The first mechanism is basically called vertical scaling. Then you will shut down one of your nodes. You will scale up number of CPU cores, amount of memory. Then you will bring your node back, and now you have more application resources as needed. The second principle is called the horizontal autoscaling, where you, for example, prepare additional cluster node, we'll join that to the cluster and keep Kubernetes or OpenShift take care automatically. And that's it, basically. And also we need to talk a little bit about the security by design, because typical cloud native applications, as the name suggests, are running within the cloud. So we need to have our cloud native application to be more secure than um, any other time in the past. So basically, the security is not some such afterthought; it is the foundation. And also, it means that security by design means that the integrating security practices is needed or is being performed in every phase of deployment and development of the cloud native applications. We can talk about mechanisms such as encryption, zero trust models, and so on, so forth. But typically, such proactive security reduces risks, ensures compliance, and also safeguards data, and in the meantime, also the user's reputation. Okay, those were such basic principles of cloud native applications. And now let's talk a little bit about the Excalibur SAM as a cloud native platform. So, yeah, cloud native architecture within the Excalibur SAM. Typical approach, Excalibur SAM is consisting of multiple microservices running as lightweight containers. So we can ensure portability, consistency across almost every environment of all customers. it doesn't matter if the Excalibur SAM runs within the cloud or on premise, or maybe in other, for example, hybrid architecture, which is also supported. So yeah, this approach means faster deployment, almost no compatibility issues, and also efficient resource usage, because Excalibur SAM does not need dedicated Kubernetes or OpenShift cluster. All the Excalibur SAM needs is just dedicated namespace within, for example, existing cluster, and that's it. Excalibur SAM does not need anything more. All right, so within the Excalibur SAM, for example, later on I will show you the scheme, what's going on behind the scenes. So we will take a look under the hood of the Excalibur SAM as a platform. But basically, every component, such as, for example, authentication, MFA module, PAM module, application database, they operate completely or they run completely independently, but they talk to each other. They are actively communicating, and later on I will show you how. This kind of approach or this kind of architecture enables Excalibur SAM to be multi-tenant as well, because if we need to create a new tenant, in that case, some specific application components or microservices, if you wish, are then automatically created within the existing deployment, existing installation of the Excalibur SAM. They are created and then running and are being managed by the Kubernetes or OpenShift cluster automatically based on the instructions of Excalibur SAM. And that's the second detail why we are talking about the Excalibur SAM as a cloud native system, because Excalibur SAM actively communicates using the cluster Kubernetes API, actively communicating with the cluster and telling him what to do, how to do, and also asking if everything that needs to be there is there and is running properly. So you can understand this as the second layer. So we are not only focused on the Kubernetes scheduler, but also Excalibur as an application is doing the second pair of eyes to take care, to monitor if everything's fine. Okay. So simply the microservices-based architecture. I was talking a little bit about the Kubernetes orchestration as well, and about the native integration into the Kubernetes. Let's move a little bit further. So let's talk about a little bit about integration with the cloud environments. So as I already mentioned, Excalibur SAM can be running within the public clouds. For example, Azure, Kubernetes services, AWS, as the Amazon vendor, then also the Google Cloud, Kubernetes services, and so on. You can also deploy Excalibur SAM in private clouds. So if you have your part or whole data center dedicated to you, you can build up your infrastructure in there, and maybe in that infrastructure there will be running some kind of Kubernetes or OpenShift or VMware Tanzu Kubernetes cluster, and Excalibur can be running within those environments as well. Then we are talking about the hybrid environments. So in that case, we can breach on-premise environments or infrastructure with the public or private cloud parts of the infrastructure. So this basically ensures the unified security and unified approach how to deploy Excalibur SAM, and also unified user experience. So there is no difference if the user is using Excalibur deployed within the public cloud or private cloud, or in maybe some kind of hybrid deployment. The user experience is still the same. And the last uh, type of Excalibur deployment is on-premise. So some organizations that do not have any possibility to use such public clouds or private clouds or their own dedicated data centers and so on, they can basically dedicate such a small part of their on-premise infrastructure and deploy the Excalibur SAM on within it. So basically, if there is any already deployed Kubernetes or OpenShift cluster, customer can utilize it to run Excalibur SAM. If not, there is nothing easier than to create a dedicated Kubernetes cluster and deploy the Excalibur on it. For example, if the high availability is not required, in that case, you just need simple Kubernetes cluster consisting of one node, or in the worst case, you can install a Docker engine and install Excalibur SAM on it. But in that case, the Excalibur SAM cannot be multi-tenant, cannot be running in high availability anymore. So there are quite few limitations about the Excalibur SAM functionality. Just in case we are talking about the Docker-based deployments. Okay, so let's talk a little bit about the Excalibur architecture. So basically, currently, we are looking under the hood of the platform itself, and I'm going to zoom a little bit to show you more details about the technology itself. So, by the way, this is one of our first designs when we were trying to design and bring the Excalibur SAM to the market. So we were wondering and trying to design such platform. So basically, this is one of the first uh, tries. And as you can see, I was talking that each component of Excalibur SAM is running as the microservice. And those microservices you can see in these boxes. So for example, here on the most bottom left corner, there is the incoming traffic from the users. It is entering, this one big box is the Kubernetes or OpenShift cluster where the Excalibur SAM is running on. These small boards means this is such ingress component of the cluster which is taking care about the incoming traffic. So it is performing the HTTPS server functionality and also performing other major or minor details regarding the user traffic. Then the traffic goes to the Excalibur SAM proxy component. Why proxy? Because it acts as a simple reverse proxy and is taking care about the user HTTPS requests. Uh, Typically, it is looking for if the traffic is incoming from smartphones, from the application, which is called a token, or if it is traffic dedicated for example, some kind of API integration with the third-party systems, or if it is traffic performed by Excalibur administrator and clicking such configuration details within, for example, security policies and so on, or if it is a traffic about PAM sessions created and running by users themselves. So this is forking the traffic into appropriate downstream microservice. So, for example, yeah, I was talking about the API integration. So there is the microservice, which is called API. Then, for example, there is the dedicated microservice, which is taking care about the communication with smartphones. So typically the token microservice. There is also a microservice called client, which is taking care about the PAM sessions on the user side, because PAM sessions is being created and recorded by other components, but this one is necessary to deliver such sessions to the users. So that's the reason why it is called client. Then in the middle, there is maybe one of the most important microservices called core, because it is performing multiple tasks. It is, for example, monitoring the Kubernetes or OpenShift cluster where everything's running fine. Maybe it is taking care about the communication with the Excalibur certification authority running in the cloud, in the internet. Or maybe it is talking to some other components, for example, component which is called mailer that takes care about the email sending. By email, I mean, for example, invitation or peer verification information or requests. So, yeah, many different microservices. Also, there is a created dedicated database high availability cluster based on MariaDB technology. So yeah, it is nicely configurable within the Helm chart value file where you can define, okay, I just want to have one MariaDB node running. It is absolutely fine for me. So you can configure that in the values of the Helm chart and deploy. That's it. If you need multiple cluster nodes of MariaDB, you can configure so, and after the deployment, it will automatically take care. It will automatically create the dedicated MariaDB cluster, and that's it. As I said, there is many other microservices taking care about the multiple operations, multiple activities demanded by users. So, for example, we decided to integrate the built-in Grafana engine to be able to analyze the logs. Also, the Loki engine, which is taking care about the gathering logs from all the microservices. So basically, if there is a necessity to send some kind of log from a particular microservice, it will contact the Loki and send him all the necessary events or logs. You can analyze them later within the Grafana interface. And maybe this part is also very important because we are talking about the multi-tenancy. And as I said, each tenant will get his own dedicated application components, and this is basically it. So there is such orchestrator which is taking care about this, and Behind the Kubernetes cluster itself, there is the rest of the customer infrastructure. And as you can see, we also divided the infrastructure to the tenants. So nicely possible to operate in such use case. It is also possible to configure Excalibur to, for example, utilize some kind of external database, or maybe in bigger companies, they already have deployed dedicated HSM hardware security modules solutions. So yeah, in those cases, it is possible to integrate Excalibur SAM into the dedicated HSM solutions. If not, in that case, the Excalibur SAM consists of his own internal built-in HSM component. Okay, basically this is it regarding the uh, application architecture. So are there any questions regarding this? Let me check the chat. Yeah, there is one question. Which Excalibur SAM microservices can be run in a multi-replica mode? And why might you want to do that? Okay. So I will zoom a little bit again to on this picture. And why we want to run multiple replicas of specific microservices? It's because, as I already mentioned, during the day there might be higher demand for example, creating and running PAM sessions. During the night, there is no such use case important. So basically, those components that are taking care about the user load and especially about the PAM sessions are scalable. I will show that you these details later on the existing Excalibur SAM deployments. And also the questions, yeah, microservices can be run. Yes, they can. And also those specified can be configured in such that they can be automatically scaled up and also scaled down if the load vanishes. Any other questions? Okay, I don't see any. So let's continue. Yeah, Azure AKS or OpenShift demo. Okay, so let's check first the existing deployment on Azure AKS, how it looks like. Okay, maybe you are all familiar with the Microsoft Azure portal configuration interface. So let's check our Azure Kubernetes services. So basically, this is the Kubernetes as a service. We call it production 1. And on those Kubernetes as a service, we have multiple namespaces created. So I will check this Excalibur for demo namespace, and we can check what's running in there. Also, I need to refresh. Okay. Okay, so yeah, you can see there is quite a huge list of multiple microservices running. Let's try to count them. How it looks like. So maybe kubectl get pods minus n, and namespace will be, excuse me, will be Excalibur V for the demo. All right. I want to count them, and I also want to exclude the table header, so I will do that. Let's try. So I want to filter the header of the table out, and let's count the number of lines. So yeah, 213 microservices running within this dedicated namespace, including all tenants' dedicated components. I'm going to log in to the deployment, and I will create new tenant. So we can check again and count again to see the difference. Okay, I'm logged in. So let's go to the tenants, create a new one. Okay. Tenant has been created. Let's check. It should be located in the end of the list. There you can see information. It is in progress. So that means those dedicated tenant components are being created on the cluster. Okay, it is already completed. So let's check again the number of running pods. Yeah, and here you can see the difference. Now it is 217, previously it was 213. That means within the tenant creation, Excalibur SAM created dedicated tenant components, not only pods, but also other items such as, for example, config maps, some secrets, some horizontal pod autoscalers, and so on and so forth. Okay. Now let's try to check also the OpenShift, how it looks like. So console. Okay, I will log into the OpenShift console. Okay, and let's check the topology of the workload. So this is basically the graphical interpretation, what I already shown to you. Yeah, basic common components of the Excalibur SAM. Here you can see, for example, that this is the dedicated MariaDB application database cluster running and consisting of 3 replicas. And maybe, for example, such component which is called core. Maybe you already remember that component, or component which is called API. It is this one, or this one proxy. And on the right side, within this quite ugly box, there are located tenant dedicated microservices. As I said, the tenant creation does not create or configures not only the microservices, but also some other items, such, for example, configuration maps. Basically, you can see that right in here. So each config map dedicated to a specific tenant. Also, I will check the list of the horizontal pod autoscalers. So right, you can see that each tenant has his own dedicated horizontal pod autoscaler configuration. The advantage of doing it like this is that, for example, the tenant 0, which is basically the system tenant itself, is, for example, working or dedicated as the configuration template. So if I need to change anything for all tenants, for example, maybe the minimum, these are number of replicas, maximum allowed number of replicas, I can configure that within this tenant 0 configuration, and it will be automatically applied to all already existing tenants. This is nice because, for example, the core component, core microservice, is checking these periodically. So it is not only checking for presence or for the actual status, but it is also comparing the configuration with those templates. If there is any discrepancy, Excalibur SAM will take care and will configure or reconfigure those objects based on tenant 0 or system tenant configuration objects. All right, let's check such scenario. For example, I'm going to do it like so. Like, okay, like so, no, like such, and also like such. I will log in to the Excalibur dashboard, which is represented by those circles. So Excalibur, like such. Yeah, I will log in. Okay, I'm in. And now I'm going to simulate such outage, for example. So there is nothing easier than to terminate or delete forcibly some of those pods running within the microservice definition. Maybe I will try to kill API. Yeah, you can see the pod is running. I will open the status details of the pod itself, and I will try to kill the pod. Delete it. It has been deleted. Now I want to click somewhere on the dashboard. Yeah, I'm getting error because I can see the pod was killed. It's not running anymore. I cannot navigate anymore. But within a few seconds, it is working again. What has happened? Yeah, the scheduler of the cluster has detected that there is no pod running because it has been deleted. Maybe the same situation as the pod has crashed or has been removed by some other circumstances, but scheduler will take care. And scheduler already did, and I'm able to work with the Excalibur SAM again. And very nicely and very successfully. There was no configuration change. Any other defects are present. So it is running like as it was before. And also the error has been rectified automatically by the cluster itself. All right. Let's continue with the presentation. So let's talk a little bit about the SAM help chart. You may ask, okay, what is the Helm chart? Yeah, basically, the Helm is, let's say, a package manager for Kubernetes clusters, which can help or which helps to define, install, and upgrade complex Kubernetes applications. Typically, the vendor, such Excalibur, will create his own Helm chart, which is flexible, can be configured with the external file, and then using the Helm utility, it can be deployed on the existing cluster. If there is any change needed during the regular operation of the existing deployment of Excalibur SAM, it is also possible. I will modify the values file, apply it using the Helm utility, and Helm utility with cooperation of Kubernetes cluster will take care about the rest. It is also possible not only to deploy Excalibur SAM, but it is also possible to upgrade as well. So if there is a new version available, you can check within documentation what has been changed in the release notes. If it is necessary for you to perform an upgrade, you can do so using the Helm utility. Excalibur SAM Helm chart includes all the necessary objects and their configuration, such as, for example, microservices, stateful set, deployments, horizontal pod autoscalers, network policies, and so on and so forth. So also, if there is any problem during, for example, the upgrade, you can easily revert to previous version of the Excalibur SAM. So it is quite useful tool to manage and keep your Excalibur SAM environment working. Maybe you can ask, okay, why to use the Helm chart? For me, it is more easier to deploy such application using statically generated manifests file. Yeah, maybe yes, maybe not. Excalibur SAM has become quite complex application, so Helm chart is really necessary in this case. So it ensures that all the deployments are quite easy to be performed, so-called streamlined, and also repeatable. For example, you are migrating your Excalibur SAM application from one cluster to another. It is quite easy to perform such task using the Excalibur SAM Helm chart. Also, as I already mentioned, the upgrades are quite easy to be done using the Excalibur SAM Helm chart. By the way, in the demo, I will show you how to do that. Also, it is possible, for example, if your environment, if you need some production instance of the Excalibur SAM, some pre-production, maybe some testing or some lab kind of environment, and you wanna have Excalibur SAM deployed in there, but very little changes or modifications, you can do so using the Excalibur SAM Helm chart. It is absolutely possible. So, for example, in the lab, there is no necessity to have MariaDB database cluster consisting of three replicas. You just only need one. Absolutely no problem using the SAM Helm chart. Okay. I was talking a little bit about the Excalibur Helm chart values file. What it really is? Yeah, basically it is a possibility or flexibility to customize Excalibur SAM to many different environments and scenarios. So I would like to go through this configuration file a little bit in details because it is quite necessary to understand what's going on, what to configure in there, and also what is possible to configure for each deployment of Excalibur SAM. First section, I already put comments in there, is regarding the Grafana credentials. So since Grafana is integrated, is running as the microservice container, it needs to be configured in advance just before the startup. So basically we define the access credentials in there. So the first administrative account, which is able then perform additional configuration of the built-in Grafana. So basically, I'm configuring here username and password for the integrated Grafana deployment. I forgot to mention that within the Excalibur SAM application stack, there is also a component which is taking care about the backups. You can configure the integrated backup solution that it can take snapshots of or dumps of application database, but it can also back up the session recordings, transferred files during the PAM sessions if necessary. So those backups are typically encrypted, so you need to somehow configure the encryption, and this is the way how to tell the backup solution with which password or passphrase it needs to encrypt all the backups. I was talking about a MariaDB instance, so again, I need to configure initial password and also type of the deployment if I need only single node or 3-node database cluster. Excalibur SAM can work or can run hidden behind the forward proxy to access the internet services. So in that case, you can configure the URL of the internet proxy right here. Now let's talk about the section which is dedicated to Kubernetes ingress configuration. I was talking a little bit about the ingress. So basically ingress is the mechanism how to route the traffic or how to enter the traffic of web applications running within the Kubernetes or OpenShift clusters. Basically within the ingress, or regarding the ingress configuration, you can configure Excalibur SAM Helm chart that you can also enable possibility to use Let's Encrypt if your ingress engine supports that. And you can test the settings in such configuration that you will tell the Let's Encrypt, okay, I wanna use Let's Encrypt test instance to be able to test my configuration, to debug that and be sure that everything's running fine. And if so, later on I can configure Let's Encrypt to a production instance. So it will then utilize production certification authority servers of Let's Encrypt. Regarding ingress, you also need to provide so-called class name of the ingress engine. Because typically you can have multiple classes configured upon your ingress engine. So you need to specify. Basically, the default value is typically a public one. Then you need to specify the hostname of your Excalibur instance. So in this case, I have configured Excalibur example.org. I will turn on my laser pointer so you can better see what I'm talking about. Okay, hostname is the FQDN of your Excalibur application or the instance of it. So you need to configure this as well. TLS. So this is configuration that is instructing the Ingress engine to take care about the HTTPS encryption. So by default, or default value is that the TLS, so HTTPS encryption, is enabled. It's set to true. And also, you can turn on or turn off usage of Let's Encrypt certificates. Next section is regarding the Google Play integrity check settings. So you will then configure that in this way. You can turn it off, you can turn it on. If you wanna use this functionality, you need to ask Excalibur to provide the Google Play Integrity Services private key. If you will obtain the key, you can then configure that within your Excalibur Helm chart. Okay, last 2 pages, not more, don't worry. HeatGap registry configuration. Basically, all proprietary developed Excalibur SAM microservices are located or are accessible on private image registry, and you need to authenticate during the access to this registry. So you need to configure Excalibur SAM Helm chart to use such key, and this key is typically provided to you by Excalibur. Now comes the storage class configuration part. Yeah, different clusters are using different storage technologies, the different storage protocols, so on. And basically, the configuration parameter, which is telling Excalibur SAM to utilize such storage, is to tell him the name of the storage class. Typically, you will have some kind of storage class created or configured on your Kubernetes cluster, and this storage should have its own storage class definition. And here you will enter the name of such storage class name, and Kubernetes cluster then will take care and provision all necessary storage objects within this storage class. Because in many cases, many users are using simultaneously different protocols or storage technologies within single cluster, because typically from SSD disks, you can create a very fast, very powerful storage, but typically those storages are not very large. So the amount of stored data is limited. Then the customer can have different kind of storage, which is based on rotational disks. And those storages are not so powerful, but they can be huge. So that's the reason why we decided to create 2 configuration parameters. One is dedicated for, or is called as standard class, and it is meant for PAM session recordings, transferred file, and so on. And the database class, which is obviously dedicated for application database. Okay, next configuration is about the AI. So AI anomaly detection. In several scenarios, you maybe want to deploy the AI anomaly detection engine. So you can tell to Excalibur SAM, okay, my AI detection is already present, and I want to enable the integration. So it is possibility to enable or disable if you are not interested using the AI technology with your Excalibur SAM instance. Set tenant deletion strategy, force or soft. Yeah, basically when I'm removing tenant, I can define two options how to delete the tenant. The force mode need that the tenant will be deleted immediately when I click delete. In soft mode, the tenant will be marked for deletion, and user will be informed within the dashboard. Okay, this tenant is marked for deletion. The deletion will occur in such and such date and time, and that's the reason why we need to somehow define it. And this is the place where we can define the deletion strategy of the tenants. Maintenance mode. Sometimes you need to put the Excalibur SAM into maintenance. So you can do so anytime when your instance is running. You just change this enabled to true. You can put some kind of message, what is going on for the users. And then the Excalibur SAM will be put into the maintenance mode. So that means the web dashboard will be not accessible for the users. And you have now enough time, enough space to perform such maintenance tasks. For example, you want to perform very nice, very consistent backup of the application database, so you can do so. Or if you need to restore such database from the backup, including, for example, the session recordings, you can put Excalibur SAM into the maintenance mode and perform such tasks. Okay, Kubernetes persistent volume configuration. Here you basically you are configuring or telling to the storage provider on your Kubernetes cluster how big you want your persistent volumes. Typical use case is, for example, here for the database data, you can specify how big you want your database storage to be. And also regarding the PAM session recordings and transferred data within those sessions. So if you are absolutely enough with 10 gigs, okay. If you want more, you can change the number as needed. And also the template supports some other customizations. For example, in my scenario, in my case, I'm running micro Kubernetes from Canonical, and those had some problems in the past to properly start up the Squid microservice and its related pod. So this was the way how to perform such customizations, so I'm able to successfully start the Squid component within my deployment. Okay, any questions regarding this configuration file? Okay, there is one. Is it possible to downgrade the rollback Excalibur SAM deployment using Helm? Sure it is. And I can show you the history of my deployment because I performed the rollback once. So you can see how it was stored as an event within the Helm deployment. Okay, I will turn off the laser pointer now, and let's move to the chart deployment demo. Okay, so the second answer to the question. I'm going to open my cheat sheet like such. Okay. I want to check the history of the deployment, what was going on in my infrastructure or on my cluster. I will zoom a little bit like such. Okay, so Helm history, and this is the name of my deployment. Let's check. Yeah. As you can see, first I installed version 4.21.1. Then I performed an upgrade. Okay, the upgrade was not so okay for me, so I performed the downgrade back. Also, I was performing additional configuration, so that's the reason why the row number 4 is almost similar to previous one. Then in the row number 5, I performed an upgrade to version 4.22. Also, I performed again some of my customizations on that version. So that's the reason why there's the row number 6. And I was still not happy with the version 4.22, so I performed a rollback to 4.21.1. So this is the answer for the question. Yes, it is possible. And also using the Helm utility, you can see the history of your environment. And if we are talking about the OpenShift, it is possible as well, because I will go here to the Helm. I will open this deployment, click on revision history, and here you can see what was going on. So principle is the same on Kubernetes and on OpenShift clusters as well. In cloud-based Kubernetes, so for example, Kubernetes as a service, the principle is absolutely the same one. Okay, so let's try to perform clear of the environment. So I will completely delete the the deployment, and we'll try to install that as the clear installation. Okay, so kubectl, which is the kube command line utility used to manage Kubernetes cluster. So kubectl, delete namespace, and namespace is called Excalibur, like such. In that scenario, I will not be able to check further details or further history of the deployment, because when I will remove namespace, I will basically clear everything regarding the Excalibur SAM and his Helm history. It may take a little bit longer to delete, but in that case, I will try to show you my values file for deployment. Okay, not this one, but this one. Yeah. So it is more or less the same as I showed to you in the presentation. Again, we are talking about the hostname excalibur.example.org. So if the installation will be successful, we can later on check web browser if the Excalibur is running, if it is accessible for further configuration. For demo purposes, I do not turn on the Google Play integrity. Also, I do not turn on the AI integration, and also I'm not using the MariaDB cluster, but only single node in this case. Okay, let's check if the deletion is complete. Yes, it is. Okay, just housekeeping to make sure that the namespace was deleted. Get namespaces. Okay, the Excalibur namespace is gone. All right. So first, I need to take care about the Helm utility installation. As you can see, I already have Helm installed. The step-by-step how to install Helm is listed within our documentation on the public portal. So you can check how to install the Helm utility. Now let's try to list the or check the list of available repositories on my Linux system. Okay, there are no. So I do not have any repositories of Helm charts configured. So I need to add Excalibur repository of Helm charts. I will zoom a little bit. Okay, so let's do so. I'm going to add repository which is available on this URL using the Helm repo add command, like such. Okay, let's check with the repo list. Yeah, now you can see the repository has been added. Now I need to perform update of such repository to download its content and to check what's available within that repository. So, Helm repo update. Okay, it is now updated. So let's check the content of the repository. Helm search, repository, Excalibur versions. As you can see, within the Excalibur repository, there is a chart called Excalibur, and these versions are available within that repository. So if you want to install Excalibur 4.21.1, you can do so. And if you want to install the latest one, again, you can do so if needed. There are also two more charts of two different versions. The one is regarding the AI model, which I was talking about regarding the integration of Excalibur SAM with it. And also there is our internal one, which is called Excalibur monitoring. This is typically not used by customers, but we are using the same repository for this Helm chart as well. Okay, so this is all done. The repository has been added, has been updated. My values file is already in place. Let's check. It is in this directory. Yes, my values file is in here. So I have everything what I need to successfully install the Excalibur SAM. So let's do so. I will copy the command from my cheat sheet. So helm install. This is the my own custom name of the Excalibur deployment. I can put any name which I need to. I am installing this Helm chart, which is, by the way, located within this repository. I'm using my customizations using my own values file. I want to create new namespace for the Excalibur since I already deleted the old one. And here is the name of the namespace. So create namespace, and I want to install version 421.1. Let's go. Okay. Installation failed. Values don't meet the specifications in the following chart. Okay, the maintenance mode is not allowed. Nice. This is basically telling me that I have something in my values file that the version 421.1 does not know. And that's because this feature came into the Excalibur SAM with version 422. So I'm going to replace the version like such, and I will try to install Excalibur again. Okay, it is thinking a little bit, and now we have the result. Excellent. Deployment name Excalibur -v4 has been successfully deployed. Date and time. Within the namespace Excalibur, it is deployed. I'm on the revision 1 since I deleted all the old revisions, and installation is complete. Okay, so let's check again what is the running status of those Excalibur components. And yeah, so cube, CTL, get pods, and I can try to see a wide output. Okay, as I can see, there are still some components they are not running. Maybe they are waiting for something, I don't know, but I can explain what's going on. Basically, first I need to check is database. Okay, database is running. That's nice. The second component that is very important is called repository, because repository is the central engine which enables other microservices to use database data. So every database request is going to repository, and repository will take care about the data select, data insert, data deletion, and so on. Okay, let's try to periodically check what is going on with my deployment. And now I can see there is already some change. The repository is already running. Fine, that's nice. The core component is still not, API is still not, but it is progressing. So we need to wait a little bit more. Also, the token microservice is still not available. It is running, but it is not available. So that means the probes I mentioned earlier are getting the information that the microservice is still not ready to perform or to get responses for requests. So during the installation, it may take a while, so we need to wait a little bit more. Okay, so the rest of the components is already running. So now we are just waiting for the token, for the core, and for the API. API is probably the last one which will switch to ready status if the rest is running and ready to serve to user requests. Okay. I will wait few more seconds. Or if I need to, I can check what's going on. So I will copy the name of the pod and try to check what's going on. So describe a pod, and this one. Okay, container has been downloaded, has been started. Startup probe is still failing. So also the readiness probe failed. So still there is something going on. Let's check again. Ah, nice. I did nothing to it and it already started successfully. Okay, so currently I can see everything is running, everything is available. So let's check the browser if I'm able to load the setup interface. So excalibur.example.org, that's the name of my deployment. Enter. That's it. Easy as that. As you can see, the installation is successful. Now the setup interface is asking me to provide additional configuration details, such as, for example, license key, to configure the email integration, configure identity store integration, and register first administrator. That's it. Okay, that's the end of the demo. Are there any questions?
It
No
seems we have
question?
no more questions. Yeah.
Okay, no question, no raised hand. All right. So thank you for your patience. Thank you for your attendance. Um, from my side, that's all for today. And tomorrow we will show you something more about the multi-tenancy and about the network policies that can be configured within the Excalibur SAM. So if you are interested in, join us and see you later.
Thank you very much. See you tomorrow.